If you want to rearrange the gravitational energy formula to solve for the mass or the height when you're given the gravitational energy, this is how you go about it. If we want to solve for the height, we start with the basic formula. And to get the height by itself, since it's being multiplied by the mass and the acceleration of gravity, to move those over when they're being multiplied, you divide them. So we divide this side by those two, but if we divide that side, we also need to divide the other side. When you do that, these two cancel out, so then the only thing you're left with this side is the height. So the height equals the gravitational energy divided by the mass times the acceleration of gravity. Now notice that these are in parentheses, meaning you have to do what's in parentheses first and take the gravitational energy and divide by that product on the bottom. Now, if I wanted to go ahead and solve for the mass, it's basically the same thing. You start with this basic formula. To get the mass by itself, you need to divide by these to move them to the other side. So divide both sides by the gravity and the height. Now, that means these will cancel out. So all you're left with on this side is mass. Therefore, mass equals the gravitational energy divided by the acceleration of gravity, negative 9.8 meters per second, multiplied by the height. Again, remember to multiply the things in the parentheses first and take the energy divided by that product. If we want to rearrange the kinetic energy formula to solve for either the mass or the velocity, it's these quick steps. You can skip ahead to see the end, but this is how it works mathematically. If we take that kinetic energy equation, we say we want to solve for, let's say, the speed. First thing we need to do is get everything else to the other side. So if we want to move the 1/2 to the other side, what we can do is multiply both sides by 2. When you do that, 1/2 times 2, the bottom 2 cancels out the top 2, and now the 2's over the other side, so we end up with this equation. So if we take this basic equation here, we say, well, we still need v by itself. We need to move over the mass. To move over the mass, we divide by the mass, and then those masses will cancel, and we end up with this equation. Twice the kinetic energy divided by the mass equals not just the speed, but the speed squared. So what do you do in order to get rid of a square? You take the square root, so you square root the both sides. Now this side, nothing's going to cancel out, but if you take the square root of a square here, the square goes away. So this is how you solve for the velocity if you know the kinetic energy of the object and the mass. Now, if we wanted to find the mass, we go back to this basic equation right here, and we say we just want to get m by itself. So what do we have to move? We have to move the v squared over. So all we have to do is divide by v squared. Now those cancel out, and here you go. The mass of the object would be twice the kinetic energy of the object divided by speed squared. When we measure energy and make calculations, we have specific units that combine together to make units for energy. So this is a very quick look at what those units are. When we take the gravitational energy formula, that's mass times acceleration of gravity times height. So the units for mass are kilograms, the units for acceleration of gravity, meters per second, and the units for height are going to be measured in meters. So if you multiply those numbers, you're going to multiply your units together. When you multiply these units together, meter times a meter is going to equal a meter squared. Seconds divided by itself twice is going to be a second squared. So this combines together to be a kilogram times a meter squared divided by a second squared. Now if we take a different type of energy, kinetic energy, that is 1/2 times a mass multiplied by the speed squared. So the units for mass, again, are in kilograms, and the units for speed are meters per second. But remember, that's speed squared, so we have to take the meters per second. We have to square that, so that's going to have meters squared and second squared. What that gives us is kilograms times meters squared over second squared. And if you take a look at both of these, they're both measuring energy, and what you'll see is that they both measure energy in the same units, kilograms times meters squared over second squared. Now, in addition to this, you can, because that's such a big mess of units, abbreviate these as a joule. So a joule is an abbreviation for the energy units, kilograms times meter squared divided by second squared. James Joule was a scientist famous in physics for showing how different types of energy can be converted into thermal energy. In his most famous experiment, he took a heavy weight which was attached to a paddle wheel by a string. As the weight fell, it lost its gravitational energy, and by falling it made the paddle wheel spin, and as the paddle wheel spun, its kinetic energy was able to move the water and turn the kinetic energy into thermal energy, causing the temperature of the water to rise.
So now it's time to take a look at some example problems using your rearranged formulas for gravitational and kinetic energy. So just as a reminder, we got a little summary of the formulas up here. You've got your gravitational energy formula, your kinetic energy formula, and then you have them rearranged for some of the different things you might need to solve for the mass, for the height using gravitational energy, and for the mass and the velocity if you know the kinetic energy. So in this first problem, we have a 7-kilogram cat stuck up in a tree. How high up in the tree is the cat if it has 275 joules of gravitational potential energy at that point? So in this tree, we've got this cat, it's stuck up at the top. Now it says that the cat is 7 kilograms. So 7 kilograms, remember kilograms measures mass. So that's the mass of the cat based off those units. It says it has 275 joules of gravitational potential energy. So off to the side, we can write gravitational potential energy equals 275 joules. And what does it want to know? It wants to know how high up in the tree is the cat, so it wants to know the height. So from where the cat is down to the ground, that's what gives it gravitational potential energy, the height above the ground. So the height is what we're looking for. So as you do this problem, you say, well, I've got gravitational energy, so we're going to take a look at that basic equation. When you rearrange that for the height, what we're looking for, you get this formula. So that's the formula we're going to use to solve that problem. It's the gravitational potential energy divided by the mass times the acceleration of gravity. So we're going to go ahead and plug in our numbers. For the gravitational energy, we had 275 joules. So there's 275 joules at the top. And then on bottom, we have the mass times the acceleration of gravity. So the mass we said was 7 kilograms times the acceleration of gravity. Now you have this number memorized still. The acceleration of gravity was 9.8 meters per second or meters per second squared. So when you do this, please remember the bottom has to be done first. That's why it's in parentheses. Now depending on what kind of calculator you have, if you don't have a calculator with parentheses, multiply the bottom and take the top divided by the bottom number. If you do have a calculator with parentheses, you can put it all in at once. Just make sure you use the parentheses. So we've got 275 divided by parentheses, the mass of 7 kilograms times 9.8 meters per second squared, and close those parentheses. So 275 divided by that product on bottom will give you, well, 4.00 something. We're going to go ahead and round it to something reasonable. It rounds right around 4. So our height is going to be 4. Now the last thing we need to make sure we know is what are the units going to be. Please remember, a joule is an abbreviation for a kilogram times a meter squared over a second squared. So when you take a look at the units on top and the units on bottom, anything that's on top and bottom, they can cancel. So kilograms divided by kilograms cancels. Second squared divided by second squared cancels. And then here we have meters squared, and down here we only have meters. So you have meters twice and meters once. So one of those meters cancels off the square. All you have left is meters. So the units or meters, that makes sense. We're looking for a height. So that height of that cat up in the tree is 4 meters based on this problem. For the second example, we have Nyla. She's at the softball game. She happens to be at bat. It says during the softball game, Nyla hits a 0.2 kilogram softball and it leaves the bat with a kinetic energy of 53 joules. What was the speed of the softball? So we take a look at what we're given. That's the how many kilograms the softball is, and again we said mass is measured in kilograms. We've got 53 joules of kinetic energy, so the kinetic energy EK is 53 joules. And then finally, what was the speed of the softball? So it's going off in this direction at some speed. So what is that speed based off the kinetic energy and the mass of the ball? So now that we're looking for velocity, we know we've got the kinetic energy. You take a look at your formulas again, and look, we got the kinetic energy formula, but we're looking for speed. And if you rearrange that to solve for speed, then you're looking at this equation here. The speed is the square root of twice the kinetic energy divided by the mass. So we're going to go ahead and write that formula down. Speed equals the square root of twice the kinetic energy divided by the mass. And then it's just a matter of plugging your numbers and remembering that the last thing you do here is square root. Solve for everything else inside the square root first, square root last. So plug in your numbers, the square root of twice the kinetic energy, that's twice 53 joules, divided by the mass, which is 0.2 kilograms. So we're going to do what's inside first. 2 times 53 divided by 0.2. We'll go ahead and plug those numbers in. 2 times 53 divided by 0.2, and that gives us 530. So our answer here is going to be the square root of 530. But then as far as the units go, remember, joule breaks down into kilograms times meters squared over a second squared. So we got kilograms over kilograms. Those are the only two units that are the same. They cancel. So we have these units. They get carried along with the number. So if we take the square root of the number, so if we take the square root, second square root of 530, what we get is, rounds to about 23. So the number for the velocity is going to be 23. And then what happens when we square root the number? That means we also have to square root the units. But if you take the square root of things that are squared, the squares will go away, and you're just left with meters per second. So that's how fast the softball was going if it had 53 joules of kinetic energy and the softball had a mass of 0.2 kilograms.